Welcome to this video where I break down this forest management plan. This is a 25 acre forest acres on an 80 acre property, and I do a lot of these. I would consider this a small plan. 25 acres isn't that much timber for the way our system is designed, but I do a fair amount of these. And this is kind of on the western part of the state where it's more prairie country on the flat, broad uplands, and most of the timber is found in the draws. So I'm going to go through this plan and just kind of point out the highlighted parts of it in some sections. This is a technical document. It's a reference document. It's not meant to be read straight through. And so this review right now is to kind of help get the folks that have one of these or that are thinking about getting one of these, just how to get your head wrapped around the information that it contains and how to find the important stuff that you need to know. So this is the cover page here, and then we just have some information about personal contact information and this is for the NRCS, the EQIP, CAP 106, and DIA 165. So this plan meets all their specifications, but it's been customized to fit kind of a little better with how I see the world and to go into a lot more detail for the client. So this plan just provides a lot more information than the standard template. Okay, here's a table of contents, and in the plan this is clickable. So on my computer I just hold down the command key and I can click this and it'll take me to it. But this is a good outline. It just kind of goes through all the different sections. If you want, you can pause and read through this. I'm not going to read through all of it. This section here is all maps. There's a little bit of other information, but it's mostly maps. This is soils, geology, and the ecosystem site descriptions. A little bit of information about them is included. And then we have the activity table. And so if you're reviewing a plan from me, it's very important that this activity table include the activities that you want to do, because this is what the NRCS is going to be looking at to decide how to sign you up. So when you call them up and say, hey, that thing in the plan, I want to do that, they can go to this activity table and it provides exactly the information they need in a line item format so they can sign you up. Okay, and then I go through existing conditions and management recommendations stand by stand. So I go through all of stand 1, and then all of stand 2 is here. So the existing conditions, that's like an inventory, a field survey. It's kind of like in real estate when you sell a property, you get a home inspector to come with a flashlight and a screwdriver, and they look in all the corners and dark areas and all the hidden areas everywhere, and they give you a report that tells you what's going on. And that's what the existing conditions is. So for the field survey, I go out and I put in plots, and I take notes, and I collect data about what's out there, and then I do a data analysis and I describe what is out there. And then for the management recommendations, I'll get into that more later when we get there. That's a lot of information there. Okay, and then just some other things that come with the plan. There's a location and plat map, soil survey information, threatened and endangered species. These 3 species, the Indiana bat, northern long-eared bat, and monarch butterfly, are listed for the whole state, I believe. So there's no special species of interest here. And if there were, it doesn't really affect what we're doing here at all. It's it's one of those federal checks that we have to make sure that we are being mindful of these species, so this is how we address them. And then there's some extra results from the data analysis at the very end. Okay, so I'm just going to go through the plan now a little bit. This first section is objectives. This is what guides the plan. So in the very beginning, I'm spending a lot of energy trying to figure out what the client's objectives are, because that's going to guide the plan. If you say you want to do something, then the plan is going to be able to tell you, yes, that's possible, and these are the steps to do that. Or that isn't necessarily applicable given the conditions. So that's what the plan is with the landowner objectives. These are pretty common, and I always put this one in. Obviously, your objective is to get a forest management plan if you're getting one of these. And then this client wants to improve the aesthetic. A lot of understory brush has grown up, and they want to nurture the quality of the timber so that it's valuable, and they want to improve wildlife habitat. Those are really common across the state. And then here's a little history on the property that the landowner provided me. And if there's been a history of timber sales that the client knows of, that's information that I need to know to go into the plan. Also, other information would be if you're doing other conservation programs through EQIP or maybe through the state conservation department. You know, if you're doing pollinator habitat, or if you're doing food plots, native warm season grass restoration, any kind of wildlife habitat management or forestry management activities, it's good for me to know to put in this section, because that ties in with the inventory and the management recommendations that follow. Okay, here's a soils map, and this one's pretty nice. I like this one. It shows how soils vary across the landscape and also how they repeat. Not all properties are this clean as far as showing that. And then I put together this little table here that shows the soil map unit. So this is the soils that's on that map. And then this is the ecological site description. And this is the code that they give it. And then this is the name, interbedded sedimentary upland woodland. So on that soil type, this is the ecological site that used to be native. And then I list what stand that soil is found in. I'll get to that later. And then the site index. So you can think of this as a productivity rating, kind of like with a farmer, of how many bushels per acre are you getting yield on your crop. Some soils are going to yield more, and that's what this is saying, that this is a rating. And technically it's at 50 years old, a red oak you can expect to be 58 feet tall at 50 years old, and a white oak would be 53 feet tall when it is 50 years old. On the Nottoway, which is the bottomland soil in this property, the white oak are 65 feet tall. And then there are no published ratings for these other species where dash is located. Most soils just have a couple trees, if that, and not all soils have tree ratings, site index ratings. So that's why it's incomplete. But this is a good way for us to just compare productivity, and we can see here that the Nottoway up here is the most productive for white oak. For red oak, it looks like the Gorin, and I would argue that the Nottoway is going to be high too for the red oak. Okay, then I provide some information about the soils to help you understand how they lay on your property. Some specific information, just breaking it down for you. On this property, all the ecosystems are woodland. And then here's some local creek and local river names that I censored out for this. And then some ecosystem landscape cross sections. Okay, here's the ecological site descriptions, and this just shows how the different ecosystems lay across the landscape, and they're based on the soils. So this is looking just like the soils, but we have different labels. And then here are from the ecological site descriptions that the NRCS publishes. These are the landscape diagrams that show where we would find a deep loess upland woodland. If we go down here, deep loess upland woodland, that's going to be number 1, which is all this soil here, and it stops at these cross lines. Stops there. So it covers all this ridgetop, and it's next to big rivers, and it's really deep loess. And if we go down here at the Gorin, it's a loess upland woodland. And we go over here, loess upland woodland is labeled number 1, and it's up here on the tops. It's not in the valleys, it's on the tops again. But it just so happens on this property, the Gorin is on the side slopes. So these aren't precise for the property. These are very broad across the big landscape. So they're general, and they're going to look a little different on the property. But I put these in here to help the landowner start seeing how the soils are influencing the tree growth. So if we have trees up here, they're going to be on a different soil than what we might find down here, and that's going to affect the ecosystem. So this is just a system for plotting out the different ecosystems across the landscape. It's very handy. I rely on it extensively. Here's a diagram that shows how these ecosystems vary across the landscape. A prairie is, a grassland with wildflowers and very few, if any, trees. A savanna is a grassland with scattered trees in it. So think about those images of Africa where you see, just big trees far off in the distance. In Missouri, most of our savanna is in cattle pastures, where there's scattered trees out in the pasture, and sometimes in the croplands you'll see really big trees that have been saved out in the middle of a crop field. And if they have enough of them, technically that could be a savanna. Savanna used to be really common across most of Missouri. Even in the Ozarks, it would be common on local areas on the Rocky Hill slopes. Then we have woodlands and forest. So I'm going to go over here on this end, and a forest is full of trees at all levels, and there's no sunlight getting through. It's really full of trees, and the trees are tall. We find these in Missouri in the bottomlands, and on this property for this plan, forest technically doesn't exist. It was all woodland. So what's the difference between a woodland and a forest? A woodland is scattered trees with light getting through. And it's a gradient. We can see that a forest, one might call this a forest here. And so as it gets more open, it becomes more woodland. As it becomes more open, it becomes a savanna. And then eventually, no trees, it becomes a prairie. Fire is what largely maintains this in most of Missouri, especially the western part of Missouri where it's more prairie country. The fires would come in off the prairie, roaring hot, and on the uplands they would burn hot, and then as the elevation would go down into the valleys, the fire would get more cool and maybe would put itself out on some years. and you would start to see more trees as you go lower in elevation into the valleys. More and more trees, and in some places you'll get even forest, maybe in broad river floodplains in the prairie country. On periods where we have a lot of hot fire, these bottomland forests can get burned through a lot and they start to look like a woodland. In periods where we don't get a lot of hot fire, maybe we have like a cool, wet period for 20 years, maybe the forest starts to grow thicker up in here, and even the prairie disappears and becomes a savanna or a woodland because trees are now growing up into it because fire has been calmed by all the wet years. So this is a gradient that's shifting, and when we manage with fire, we can control this. So right now, a lot of the forests in Missouri haven't been burned, and they have closed canopies like a forest, but they don't have the tall trees. And so we still classify them as woodland. We just call them overstocked or degraded woodlands because they haven't been managed. Most of Missouri was woodland savanna, and we can use fire to control where we want to be on this spectrum, and we can move it around. Nature's not really static. Okay, so then in the plan, I just give a little details on geology. On some properties, geology is really important because soils are thin and the geology is exposed, and it's really influential. On some properties, such as the one that this plan is for, the geology is all buried, and so it's really not that influential. It's buried quite a bit by loess. Just a little more breakdown of soils, and then here's some tips on how to keep water from leaving the property. And you'll see there's a lot of goalies, so there's a lot of work that can be done. Then I spend a moment talking about soil biology. Soil biology is, really critical to forest management. So if we can have a really healthy, diverse soil biology, we're going to see a more resilient forest, woodland. In times of drought, it's going to be more resilient. And insect and disease outbreak, it's going to be more resilient. So I throw this in here to kind of help you start to see little ways that you might be able to influence soil biology. Okay, forest productivity. I talk a little bit about forest productivity. Some areas produce big trees, some areas don't produce big trees, and so this kind of breaks down why. And then this is kind of a long history going back to indigenous prior to settlement, to give you an idea of the native vegetation and the potential of the property and how different the property looks now compared to what it used to look like. Okay, and now I'm going to start going through all these maps, and I'll just give you a little information about the workflow for making these plans. This is a plot distribution map. So to do the forest survey, to do the inventory, to get the data, I go out into the woods and I stop and I put in a plot, and at each plot I measure the trees and I turn them into code and put them into a data analysis data set. So these are all the places that I stopped, and you can see this was the first place I stopped, and then I went down here and over here, and I walked through all this. Even though I didn't put plots, I walked through all of it. The reason I didn't put plots here is because there's not enough space. These plots are kind of big, not as big as my cursor. I'm exaggerating a little bit, but maybe as big as a star or a little bigger in some cases. And big trees can actually be a lot further away than the edge of the star. So these areas aren't big enough. So in this case, what I do this on all the farms, is I just walk through here and I start writing down the trees that I see and their size classes and their logs. So I'm kind of making a data set, but I can't analyze it. it just goes into my notes, and then when I'm describing all this to you, I have very good details about what's out there. And then up here, I wished I could have put in another plot or two, but this got too narrow, and the goalies were pretty wide with no trees in them, so they kind of influenced the plot too. And then these areas were too small to put plots in. And so what I do is I lump them based on their soils and their ecosystem. So all these blue areas are the flat bottomland, and they're all pretty much the same as far as the tree species. And so I was able to lump them. The big variation is it's old field. All of this was farmed, and it was piecemeal, slowly at a time, slowly over time, allowed to reforest. So you might have big trees here and really young, small trees right here on the edge, especially up in here. And the same applies for stand 2, the green stand. There's a hodgepodge, a variety of age classes, but pretty much all these areas are consistent as far as what species they have and what trajectory they're growing towards. And so these are all lumped together. And then per the NRCS standard, there's a lot of different maps and styles that have to be made, and they want a map with these labels on it. So it's kind of hard to look at, but also along with all the other maps, this one's not bad, it's convenient. Here's one color coded with the labels. And then I took off the acre labels. Just put the parcel labels on this one because it's so busy. I usually don't have this many parcels, especially on plans this small. But that's how it lays, and the inventory records what is existing. And so this is a detailed map of what is existing. If the manager wants to, if the landowner wants to, they can manage all this together. Or they can subdivide this and break it into smaller pieces. This is just a survey of what the existing conditions are, how they were found. Okay, all these are winter photos. So in the winter, the deciduous trees don't have leaves, and the cedar trees do. So I like the winter photos. This is kind of a low quality image. And I'll tell you, one of the nice things about these digital plans is you can zoom in. But I made this image low quality keep the file size low on the plan. And I share high quality images with the client when I give them the plan. But I like this one because we can see trees. If this was the high quality one, you'd be able to see trees or their shadows. And then we can see where the cedar are. So this is on the neighbor, but there's a little cedar on this farm right here and right here. And then just scattered trees here and there, but there's no thickets really too much. So this is a winter photo, and then this is a summer photo. So all the leaves are on the trees, and I don't generally use this one that much at all. The winter one is my preferred photo. It's hard to distinguish where the cedar are at. But this one's high resolution, and you can see individual tree canopies. But I'll show you an even better map for that. Okay, I'm going to zoom back out a little. This is a hillshade map. This is the surface of the earth. So this is remove all the vegetation. What does the skin of the earth look like? Every wrinkle and pimple. And we can see here the neighbors got some terraces. Looks like they're active, they're not old. We can see old plow lines. And we can see those plow lines in the forest, in the bottomlands. So every acre on this farm has been plowed. And then these are really nice for seeing the gullies. So I really like to work on these gullies and get them cleaned up. It restores the hydrology. It keeps soil on the farm. It keeps water on the farm. It raises the water table. So I really love to do work on these and try to repair these. And we always start up here on the top. There's a few things we can do down here on the bottom while we're working up here, but up here is where we're going to start making the first difference. And as we improve it up here, we continue moving downslope. And we can see if we improve this gully here, it would really reduce erosion in the field and probably run off across the entire field. Okay, a little off track there, but we can see there's a lot of gullies. And this is pretty common on Missouri farms that were farmed heavily in the past. You know, it may not be farmed heavily now, but it has quite the history. Okay, this is also made from point cloud data, and this shows the percent slope. So the red means it's more steep, and the edges of the gullies are like walls, and that's what's showing up on this red lines here. And then the blue is flat ground. The green is mildly sloped. The yellow is heavily sloped, and then we can see red is more steep. This is a pretty nice map, especially where we have a lot of variability in slope. This is an aspect map, and this one's a little difficult to read, especially on this property. On some properties it's more clear. But the yellow is facing south. The hill, the slope, if you were standing up here looking down this way, looking south, and started walking downhill, that's the same way the water would drain. And then over here, the slope is facing to the west, and that's what the red is. The blue is facing to the north, and the green is facing to the east. This is not that useful on this property because we don't have a lot of topography on this property. But on properties with a lot of topography, these maps can be really useful. Then here's an elevation map. So blue is the lowest, and then we get a little higher in elevation. In the bottomlands, we get into green, and so on, up to the highest elevations, which are red. And the blue for this map is 700 feet above sea level, and it gets almost 800 feet. And then this is a canopy map. So this is the LiDAR, the point cloud. And what they do is they shoot beams, radar beams, similar to radar. And they bounce off an object, and when they return to the camera is able to then do that a millions of times and come up with this really nice image, and they can tell you if it bounced off a tree or if it bounced off the ground. So here are the trees. I put them on this map. I'm gonna zoom in, and this is really nice because we can see how the tree canopy lays. We can see like there's some taller trees here, but then the rest of this area is short trees, and in fact here is really short. And this area was actually a lot of shrubs with just small tree saplings in it. It wasn't very old yet. Here we've got some big trees scattered on this end, and then there's not a lot of big trees, and then we get in big trees up here on this end. Here's a patch of not that many big trees, not that big of trees. So this is really useful for helping a person just look around on their property, figure out where all the big trees are, figure out where the small trees are, and help you prioritize whatever kind of work you're trying to do. I really like these maps, and the more I use it, the more I like it. Okay, and then for the NRCS, for the Force Management Plan, the CAP DIA 165, they want a modified burn plan. So in that modified burn plan, they want suggested burn units, and that's what these are here. After this plan is done, to continue with the NRCS pathway, you would need to get a burn plan, and this would be finalized. So these are kind of the burn plans that the client and I worked out. Like, what do you think you would like to do? And we discussed it, and this is kind of just a rough draft of the different burn units. So this is a gravel road, a county road, and on this one we figured burn all the grass on the south end and then just wrap it around all the timber on the rest of it. And then on the south one, break it into 1, 2, 3, 4. I messed up on this map label. So there's 4 different burn units down here. And again, this is just suggested. This one could be divided up. These could be divided up. These could be combined. And I think over time, it's good to mix these up and not stay with a fixed burn unit template over time. In some cases, it might be good, but in a lot of cases, I think it's good to mix it up over time. Okay, and then as part of the plan, they also want to know the distance of the type of fire line. So here are the types of fire lines. The blue is hand line, green is mowed, red is road, yellow is row crop, and then the distance in feet for each segment. Okay, and then here's just a short narrative of what the stands are, what makes them a stand, what makes them different. Here's a breakdown of the acres, and then here's some things that need to be getting done regularly. And then this plan is good for 10 years. So in 10 years, the trees are going to grow, they're going to change, some of them are going to die, some of them are going to get sick, all the ash trees are going to be gone. And so you're going to want to get a re-inventory. Okay, this is the activity table. And if we are working together for you to get one of these plans for the NRCS, this activity table needs to be reflective of what your intentions are for signing up for future EQIP contracts. So not all these are eligible for EQIP cost share. The ones in bold are. So I'll go through this. It's got the stand. It's line itemed by the activity and by the planned date. So in a sense, this is a priority table. The first thing you're going to want to do is get a burn plan. Let's go down here. You're not going to want to do the force stand improvement first. You're going to want to get a burn plan. And at the same time, you're going to want to get fire breaks. And the NRCS has a practice. They can pay for some fire breaks to get installed, and they can pay for the burn plan. So these are now in here, and this client is now in the pipeline to sign up for future EQIP contracts. The DIA part of the EQIP contract is basically doing some advanced application paperwork. So after you get this plan, you're in the pipeline, and you've actually been pre-filed. All you have to do is call up and say, I'm ready. You're going to have to do more than that, but that's your starting step. This is a communication tool between you and the NRCS staff. And so we want to make sure that it meets your needs. Okay, so this is a practice that they don't fund, but it's kind of my wish list, and I hope that they start funding it. And there might be other practices or other agencies like the Soil Water Conservation District that might be able to help out to provide some assistance for that. So it's in the table, but it's not bolded because it's not available from the NRCS at this time. Brush management is the name of the practice for controlling invasive species. So I did find a little bush honeysuckle, not too much, and I found a little Japanese honeysuckle. The NRCS will pay for treatment if they're found on the property. So we got them in here, and that goes up front. That's something that needs to get started on ASAP, and it needs to be monitoring with quick follow-up treatment every year. Even though it's not in the plan for every year, monitoring and treatment need to be conducted every year. It's not in here over and over again. It's not in this table because they don't pay for the monitoring. If you find an establishment at a later date, you can then talk to them about getting help paying for treating the establishment. However, if you get them treated and you do annual inspection, you're going to take care of them before they get out of hand. And treatment is going to be pretty easy. Okay, so then recommend a series of controlled burning. The client's goal was to reduce understory brush. There's a lot of coralberry, buckbrush, and understory saplings, hackberry, elm. I can't quite remember right now. Ohio buckeye was in the bottomland, I think. And it's really thick, especially along the edges. So a TSI would just make it thicker. A forced thinning would make it thicker for sure. And a forced thinning would release all that stuff. So the buckbrush and coralberry would grow to 6 feet tall or 5 feet tall instead of 3. So the up front start burning, and I basically alternated burn north of the road 1 year, and then the next year burn everything south of the road, and then go back north of the road, south of the road, north of the road, south of the road. After you've burned 3 times, then you can do a forced thinning in the understory and reduce the small trees with the chainsaw. The burning's going to reduce them, but it's probably not going to reduce all of them. And so this is going to help speed that process up. And you should have a lot of native grasses and wildflowers growing because of the burning, that when you do this chainsaw thinning of the small trees, it will release them, and they will get more healthy and more abundant, more thick. Okay, after every burn, I recommend that you seed in native plants. And I don't necessarily recommend that you seed every acre as it shows in this activity table. And the NRCS doesn't fund this practice until you've burned it a few times. So I just left it unbolded, and you and the NRCS planner can decide later if it qualifies. In the meantime, what I recommend is every year collecting seed off some places on your property where you have native plants growing, or other properties where you can get it legally with permission, and to purchase seed. And after every burn is the ideal time to spread it, and so then you can go and spread that seed after every burn. And you don't have to do the entire area. You don't have to do an entire acre. You can just do 1 handful. I would do as many handfuls as you can, maybe a sack or 2. And you just go and spread it around. Don't put all your eggs in one basket, so you want to spread it around. And some areas it's not going to germinate, some areas it's going to germinate and not survive, and some areas it's going to flourish. And so that's why we want to spread it around and just let it spread itself from there. In later years, if the NRCS decides that it qualifies, they will pay for you in this practice to do every single acre with a high density of seed. So at that point, you would have a total transformation. And the reason they want to wait is because they want to see what comes up naturally before they drop all that investment. Native seed is expensive. After this thinning, continue burning, continue nurturing that understory and shrub layer and ground layer, and then come in and do a thinning in the overstory and midstory for both stands. And then continue burning. That's not included here on this table, but then you're going to continue burning. And then these last three practices are just alternatives that you can do anytime on any size place, and it's plant trees or shrubs. Forest farming, so that would be planting like ginseng or black coche or pawpaw. And then edge feathering, which is along the forest edge, field edge, 30 by 50 foot units where you drop all the trees out into the field. So these are things that definitely can be done, but the landowner did not express interest in doing them at this time. I threw them in here so if the client changes their mind in 5 years, they're going to still be in the pipeline and eligible. Okay, so now here I go through every stand, and I'm not going to do this for this video, but I am just going to hit some highlights and kind of explain how it works. So the first part is just some general details about the stand. So it's the bottomland woodlands. It contains different parcels. The aspect, because it's a flat bottomland woodland, the aspect isn't influential, and there's not much slope. So all these general details about the entire area that is stand 1. And I even go through wildlife, talk about a little history, talk about the gullies, about the soils, slopes, just some general information. And then start to get into the data analysis. And this is stand-wide data analysis. So the stocking rate is kind of, like think of if you were planting corn in a row crop, how stocked are they? Do you have a lot of them in there? Do you have not too many? And so we can do that with forest as far as the trees. Is there too many? Is there not enough? And this one is fully stocked, so it's right on the line. It's not too bad, and it's a good spacing to have in the theoretical model world. Okay, so then I just go through details, and I break it down by overstory, midstory, understory. Here's how many trees per acre we estimate for all the size classes. Back to the stocking. Snags, there's estimated 2 dead trees per acre, and there's estimated 8 trees per acre that have a visible cavity in them, a den tree. The average diameter at breast height, it was almost 8 inches. The stand age was somewhere between 40 and 60. It was kind of variable. The dominant tree height is 60 to 80 feet. And we can estimate how many board foot of volume there is per acre. I'll go back up here. The total estimated basal area. Basal area is how many square foot the trees take up. So it's a rating. And it's just a way to compare, and it's it's not that meaningful unless you just really want to get into the data. But if we're trying to understand your woodland as a landowner, this number isn't that meaningful until we start breaking it down. 74 of that 92, these are square feet. 74 of that is AGS, what we call AGS. That's acceptable growing stock. 18 of that is UGS, unacceptable growing stock. So this is good information to know. We kind of see a ratio here of how many quote unquote bad trees to good trees that we have. And then from this number, we can see how much is in the overstory, how much is in the midstory, and how much is in the understory. So the understory doesn't have much compared to the mid and the over. And we can go through all this in detail if you have one of these plans and you need more information, or if you get one of these plans. For now, for this video, I'm going to stop going this deep and just kind of break down the plan a little bit. I provide a little more data interpretation and just some details about what was found. Then we go into the overstory trees greater than 12 inches. And so these are all the trees that are over 12 inches. The DBH is their diameter, up to 22 inches. And black walnut was the dominant tree. It has the most BA per acre. It occupies the most square footage, quite a bit compared to the next most dominant species. So this is a highly detailed breakdown, and we can go more detailed if desired. So after this table, I kind of go through and explain it all and really break it down. What does it mean? Why is it like this? Just more details to kind of back up the data analysis about why we're seeing what we're seeing. Here's the dominance of the species. So these three are really low dominance compared to these three. Do that for all the overstory species, and I even include species that we're seeing off the plot. So these did not make it into the data, but they do exist. And so that's one thing that I really try hard on, is making sure, paying attention between the plots, and getting a complete picture of what's out there besides what was just seen on the plot. Okay, and then here's the same thing for the mid-story size class, which is all the trees in the 6 to 10 inch diameter range. And then here we have the understory trees, and this is all the trees less than 6 inch diameter, which in this stand is not very many trees. Around the edges it was really thick, but once you got inside the stand it really wasn't that thick. And then we have shrubs and vines. So I just kind of talk about the shrubs and vines that I saw. These aren't in the data, so I can't do any data analysis on them. And then these are the plants that I saw on the forest floor. This is not a complete botanical survey, and I did not collect them on a square meter plot system that can be analyzed. These are just a list of the plants that I saw on the plot and between the plots. And this is seasonal. If I was out here in April, it would be a completely different list of plants. Some of them would be there and some of these would not. Okay, and then we care a lot about oak regeneration, so there's always a note about how much I saw, and this is a really common statement. It doesn't change from plan to plan. Oak regeneration is sparse. And this is another reason why we utilize fire, because after fire, oak acorn germination rates go up a lot. Oftentimes after fire, we will see a carpet of oak seedlings. And so lack of fire has led to conditions where there are no oak seedlings, and that's pretty easy to change with burning. And then these are the oak seedling, or the, I'm sorry, these are the tree seedlings and shrub seedlings that I saw on plot and off the plot. And I only saw like 1 or 2 bur oak seedlings and a couple of shingle oak. Okay, and then here's the landowner objectives, how they apply to stand 1. Desired future condition, back to this basal area, 70 square feet. And then recommendations. So this is the activity table in a little different format. I go through and I explain, well, what is treating bush honeysuckle? What does that look like? And so I just provide a workflow that you can use to treat the bush honeysuckle. And I also provide other documents with treatment methods. So then I go through step by step. These are the things that you can do to meet your goals. Get a burn plan, develop fire lines, do a burn. These are the goals of the burn. How to do the burn. Spend a lot of time talking about how to do the burn here. After you've burned enough, as I said before, then you can do some thinning. The burning is site preparation for the thinning. If you do the thinning before you do the burning, you're going to end up with a lot of coralberry and Ohio buckeye and hackberry, undesirable species coming up. But if you do the burning, then you're going to have oaks and a lot of desirable species that come up after the thinning. So we want to wait to do the thinning until the burning has done its work. So here's some details on how to do the thinning. And here's the goals of the thinning. And then here's an alternative method. So the thinning that the NRCS conducts is a 1-entry thinning where they come in one time and take out all the trees. And in many cases, a more gentle way is to come in every year and take out a few trees. In many cases, that's going to be a lot more healthy because it's not this big disturbance that's happening in the stand. It's really unnoticeable as far as stand level disturbance goes. You're just taking out a few trees. In the beginning years, you're just going to be taking out small trees. As you get that understory in shape, then you start looking up, taking up a few mid-story, and then move into the overstory. So over a 10-year period, you end up with the same result. It's just done more gently, slowly over time. However, that method does not qualify for the NRCS funding. And so most people do the 1-entry. After that, burn more. And then the secondary alternatives of forest farming, planting trees and shrubs. A note on planting trees and shrubs, I recommend that clients practice first because the NRCS is a big investment and they're going to expect some survival. And if that survival is not met, then they're going to expect a replanting or a payback on the funds. And so practice keeping them alive before you go out and plant several hundred of them and have high mortality. Get a system figured out. How am I going to water them? How am I going to keep the weeds off of them? And get a system figured out that works for you, and then scale that up and apply for the NRCS funding and do it on a bigger scale. There's a lot of other practices. Well, not that many. There are a few other practices that the NRCS has that folks will get in these plans that are not in this plan. And there's some practices in here that won't be in some other plans. It really depends on the person, the client, and the property, on what's applicable, what's possible, and then what's desirable. Okay, so then start all again on stand 2. Go through the existing conditions. This is what I found. And this is the recommendations. And I don't spend near as much time explaining them. It's more line item. Do this, do this, do this. It's in sequence. If there's something different, then I do slow down and spend a little more time talking about it. And that is the nuts and bolts of the plan. The rest of this plan is for the NRCS standard, and I'm just going to go through it really quick. I took it out for this video, but a map is here and a map is here, showing us where the properties are located and the boundaries. Here's some soils information. This is pulled directly from the Web Soil Survey. I copied and pasted. I downloaded a PDF off the Web Soil Survey that provides these descriptions, and then I pasted them in here. And then threatened and endangered species. These are listed statewide. There were none that were listed for the property. Sometimes they're listed for the property, or if the property is next to like a major stream or the Merrimack River or something, there'll be a fish or a hellbender. I had one not too long ago with the hellbender along the Merrimack River. So basically, we have to make sure that none of the recommendations in the plan are going to disturb the endangered species. So statewide, for the Indiana bat, the NRCS has these special regulations. Do not cut roost trees between April 1 and October 31. What is a roost tree? It's a tree with shaggy bark. It's large. It's hollow or dead. Basically, can a bat climb up under a loose piece of bark? And dead trees will have these big plates of bark that are flaking off, and the bats will climb up underneath them. And they will roost. And so the NRCS statewide, or it changes across the state, I think, they have this policy. That's the only policy that really comes down from these. The rest, beyond the bats, the butterfly, and then there's bald eagles, a pretty popular one, and then usually fish if they're close to a stream. They don't necessarily have these strict EQIP policies, NRCS policies, but we do need to make sure that we're not doing anything to hurt them, and what are some things that we can do to help them. And for the monarch butterfly, one of the best things that we can do to help them is burn more often, get more native wildflower species growing, and then we can plant native wildflower species, especially milkweed. And then here are some brief data analysis results. This is standard NRCS template, and I can provide more customized results upon request. And then here's just a breakdown of how fit the data is. And that is the end of the plan. So like I said, it's not meant to be read straight through. It's a reference document. And specifically, you're thinking, hey, I would like to go mushroom hunting. Where can I go mushroom hunting? And I know mushroom like to grow under elm trees. Here's details on the elm. These are mid-story elms, so I didn't provide as much detail as overstory. But I don't think there's a lot of elm in the overstory here. In this case, there's not a lot. They're still in the mid-story. In 10, 20 more years, there'll be a lot more in the overstory if Dutch elm disease doesn't get them. So that's just an example for mushroom hunting, but let's say you want to do some forest thinning. Well, here we have a breakdown of how many undesirable trees are out there. How many of them are mature? How many of them are like coal? I was going to say like junk. So we have these really fine details that can really help us understand what is out there a lot better. And it helps us make reliable estimates about what we need to be doing to get our goals met. And you can come back and look at this in 5 years, forget all about it, pick it up and look at it in 5 years, and you're going to know a lot of details. This is pretty standard plan that I write for the NRCS. Some clients ask me to customize them. Maybe they want data collected on a little different information or analyzed a little differently. And we can customize these as needed. Yeah. Okay, I think I'll stop the video right there. If you have any questions, please feel free to reach out. My website should be provided on the channel page. And please leave a comment and like the video if you liked it. If you have any suggestions for other topics that you'd be interested in watching videos on, let me know. Thanks. Have a great day.
Honey on a honeycomb, dripping down inside the hive. Summer, golden rays shine down, climbing trees since I turned 5. I see honeybees from the ground, in the branches, see them buzz and round and round and hide the nectar from pink and yellow butterflies, dancing on their flight back home. Bees have ways to sing and sigh. I hear honeybees making sound. I'm in the branches while they zip around and round and flying to the kitchen door. Know what's waiting while I run, dipping into honey, slowing down to taste the sun. I twirl honey upside down. I'm catching rain.